Alright, I've attached the note paper I'm going to use to this activity, but I don't have the paper with me at home, so I'm going to do my notes on notebook paper, and what we're going to work on today is dividing rational expressions. So let me just start out. This can be presented in a couple different ways. You can only divide roots if you have the same root. So they both have to be a square root, they both have to be a cube root, fourth root, whatever. You can treat the problem as two separate roots, or you can treat the problem as a single fraction under one root. So what we're going to work on first is trying to simplify roots that we're dividing. And so I've got the problems written down here, and if you're using the note paper you already have that. Okay, so what I would tell you to do, check to see if you can actually reduce the fraction or divide in any way before you do the problem. So this would be equivalent to the cube root of negative 81 divided by 3. You can actually do that. Negative 81 divided by 3 is negative 27. And then see if you can do a cube root. This is a perfect cube in this case. The cube root of negative 27 is negative 3. So that would have been my answer to that question. Okay, now the second problem there, I'm going to rewrite this just real quick. This is the same thing as the square root of 243 divided by 27. So I'm just going to check on my calculator to see if that divides, and it does. This then simplifies to be the square root of 9, and so then the answer there is 3. Same concept with variables. I'm going to treat this like the square root of 12x to the fourth over 3x. In terms of the numbers, 12 divided by 3 is 4. And where do I have more x's, the top or the bottom? Well, the top right there. And I have 4 here, 1 here, so I have 3 more on the top. This is no longer a fraction. Okay, now this is going to come back to some skills we've been working on because x to the third is not going to be a perfect square. So I'm just going to do one step and rewrite that as x squared times x. That's still going to be x to the third, but this allows me to remove any perfect squares. The square root of 4 is 2. Square root of x squared, remember square root has an index of 2, so exponent divided by the root there would just give me an x. This x is going to have to stay under, so this problem's answer, 2x out in front times the square root of x. Alright, just a couple more. Again, what I would tell you to do first is try to see if you can actually divide. So I'm going to take 162, divide that by 3, and you guys are not able to see this on the screen at all as I'm looking at my calculator. So that's what I'm doing on my calculator. If you do 162 divided by 3, that is equal to 54. So this is going to be cube root 54. And I have 3 more h's on the top of that, so this would be h to the third. Now, I did not do any cube rooting here, I just simplified the fraction. 162 divided by 3 is the 54. H to the fifth over h squared would leave me 3 h's up here, and so no more fraction. Okay, 54 is not a perfect cube, but 54 is the same thing as 27 times 2, and 27 is a perfect cube. And h to the third, that is a perfect cube because my exponent's divisible by the root. So this will come out as a 3, this will come out as an h, 2 left under the radical. So answer here would be 3h times the cube root of 2. The next question, I'm going to do 192 divided by 3, and that's 64. Now, I'm going to have to leave this as a fraction here, so think of this all under a cube root. 192 divided by 3 is 64. Now, I have 7 more m's on the top. I don't have any n on the bottom of this fraction, so that's not going to change. And then what I would tell you to do, if you still have a denominator, go ahead and break down the numerator and the denominator separately. So the top of this, 64 is a perfect cube. I'm going to rewrite m to the 7th as m6 times m to the first. I'm trying to get an exponent that'll be divisible by my root. The bottom, the cube root of n to the third. Now, the top of that fraction, we'll be able to plot a 4. That's the cube root of 64. m squared, that's the cube root of m to the 6th. This is still going to be under the cube root on the top. The bottom will just become n. So I will have a fraction for my answer. 4m squared on the top, cube root of m, and then on the bottom just a letter n. And then I have one more practice problem. This one's under a 4th root. I'm going to take 1024 and divide it by 4. If I do that, I'm going to get 256. And I have 14 more x's on the top, so x to the 14th. Did not take a cube root in any way, shape, or form there. I'm just reducing that fraction. Now, 256 is a perfect cube. That's 4 to the 4th power. So I'm going to leave that alone. Okay, in terms of 14 and 4, that doesn't go in evenly, so I'm going to rewrite this as x to the 12th times x squared. 12 is going to be the highest power I'm going to get out of that to be able to divide the exponent by the root. This is going to come out as a 4. This is going to come out as x to the 3rd, and the x squared is going to have to stay underneath. So 4x to the 3rd times the 4th root of x squared. Alright, now everything on the front ended up turning out to have a nice denominator of some kind. So what we're going to work off on the back is if that doesn't happen. Hopefully you guys have done this in Algebra 1, but what we're going to talk about is rationalizing a denominator. Now, you've probably done this with square roots, maybe not with anything of a higher index like a 3rd root or a 4th root, so we're going to go through how to do that here on the back. Rationalizing the denominator, the reason behind this is it's not considered a simplified question if you have any kind of a radical, square root, cube root, 4th root, 5th root, whatever. Not allowed to have that in the denominator of the fraction. Totally fine to have a radical in the numerator. That is considered simplified, but not in the denominator. What you're going to do to get rid of that radical in the denominator, if you have one, is you're going to multiply by 1. And I put that in quotation marks because it's going to not look like the number 1, but it'll be equal to the number 1. That way we don't change the value of the expression. And we're going to manipulate that in a way to make whatever's in the denominator a perfect square if we're dealing with a square root, cube if we're doing with a cube root, 4th if we're doing a 4th root, etc. And then we'll be able to simplify and not have a radical in the denominator. So, again, if you're following along on the note paper, these should be the same questions. I just wrote them on my notebook. So, let me slide this up actually a little bit, guys, so we're not seeing this white screen. So I got multiple examples here to give you an idea. They're all a little bit different. This first one, I can't have a radical 3. So what you want to do is try to multiply 3 by something to create a perfect square. So you can always multiply something by itself to create a perfect square. So 3 times 3, this would end up giving you the square root of 9. The top would be 6 times the square root of 3. This is equivalent to 1. Radical 3 divided by radical 3. So we're not changing the value of the expression, but we're manipulating it so we can get rid of the fraction in the denominator there. Now, what's going to go on here, this should become a perfect square, which it is. This is a little bit extra simplification. This is going to be 6 radical 3. The denominator is going to simplify to 3. Now, a lot of times when you do this, this is tempting. Don't touch this radical, though. This is a square root of 3. That's different than 3. In this case, as long as we don't have any adding or subtracting, which we don't, we have a product here on the top, if you can actually reduce this fraction or divide, you can simplify, but do not change anything under the radical. So this final answer here, 6 divided by 3 is 2 times the square root of 3. Okay, question right next to this. Sorry guys, this is a 7. Both the numerator and denominator are under a square root, so we can treat them together or separate. 7 is not divisible by 2, so I can't reduce that fraction. All I'm going to do here, just whatever's in the bottom, just make that into a perfect square. So if I multiply 2 by 2, that'll create 4. In this case, the 7 and the 2 get multiplied together under the square root. So this would be the square root of 14, square root of 4. The 14 under the radical on the top does not break down in any way, shape, or form. The square root of 4 is 2. So that would be the simplest radical form, no radical in the denominator. And then one more just real quick. We're going to do radical 3, radical 3. This is going to become 2 times the square root of 9 over the square root of 9. And we could do that, or I could have probably just done that from the beginning of the problem if I didn't want to go through and rationalize that. So answer here would be 2. Okay, now different ball game when you're talking about a cube root. So in this case, alright, so I jotted down here the first few perfect cubes. 1 to the third power, 2 to the third power, 3 to the third power, and on down. So if you're dealing with a cube root, you have to create a perfect cube. So I have to think about, okay, what can I multiply 3 by to get one of these numbers? I know 3 times 9 is 27, so I'm going to multiply by the cube root of 9 here. Now remember, when you're dealing with the cube root, the breakdown might look a little different, but what I'm going to go down with here, everything's under a cube root. 2 times 9, this will be the cube root of 18 on the top, cube root of 27 here on the bottom, and so we're going to end up with the cube root of 18. This is a perfect cube, which was our goal, over 3. Don't divide these. It's always tempting. This is not 18. This is the cube root of 18, so you cannot be writing cube root of 6 here. You don't want to do that. This is your answer, and 18 actually does not break down any farther. It's not divisible by any perfect cubes. If we had this under a square root, that would be a different story. Okay, now in terms of the number 4, I could just get that up to 8, multiply by 2. Whatever I do to the bottom, I have to do to the top. We're multiplying by 1, so we keep our equation balanced. Now, in terms of a variable, this is y to the first. If I want a perfect cube with a variable, I need something that's divisible by 3, so I would just do a y squared here. When I multiply these, that's going to get my exponent up to being a 3, and that will be divisible by the cube root then. So my next step here, straight across the top, we'd have the cube root of 10y squared. The bottom would be the cube root of 8y to the third. This, as we've created it, should be a perfect cube here. The top, 10 is not divisible by any perfect cube, and y squared, this exponent, is not divisible by the root. So this is just going to stay 10y squared. The bottom, cube root of 8 is 2, cube root of y to the third is y. Again, don't cancel anything out. It's tempting almost always on these questions. And the last one in this line, all I got to do here, get my exponent up to being divisible. So I'm going to do the cube root of w squared, multiply these guys, that'll change my exponent. Now on the top, we're going to have 2w times the cube root of w squared. That can't be simplified. The bottom, the cube root of w to the third, our whole intention to get rid of that radical. So the top will remain the same, 2w to the third, cube root of w squared, the bottom, just w. Now in this particular case, no adding or subtracting, we're just multiplying here. These can actually go. Those w's can cancel out, so my final answer here would be 2 times the cube root of w squared. Okay, just jotted down some perfect fourths. These are fourth roots. So now I need to multiply the denominator by something to get a number on this list. So sometimes these are a little bit trickier and you got to think about them for a second, but 3 will go into 81. 3 goes into 9, so I know it'll go into 81 also. If you're not sure, just take your calculator, divide 81 by 3, and that'll tell you what to multiply by. In this case, it's going to be 27. That's going to be under a fourth root. Whatever you do to the bottom, you do to the top. The goal here, because we have a fourth root, is to create a perfect fourth. So the top, I'm just going to do 4 times 27. This is the fourth root of 108. The bottom will be the fourth root of 81, which is what we want because that's a perfect fourth. And in this case, 108 actually cannot be broken down under a fourth root. It's not divisible by 81, it's not divisible by 16. So the top is just going to remain the fourth root of 108. Can't break down any further, no perfect fourths to pull out. The bottom here, fourth root of 81, is just 3. And again, don't divide the 108 by 3. That's the biggest temptation people have. This is just the number 3. This is the fourth root of 108, not 108. Final one here, to create a perfect fourth with the number 2, the lowest number I could get that into on this list is going to be 16. So what I would do is multiply 2 by 8. That'll get me the 16. And then in terms of my variable, I just need an exponent that's divisible by the root. So this is squared. We're going to go ahead and make this also squared. That'll give me y to the fourth. Whatever we do to the bottom to create that perfect fourth, we have to do to the top. That way we're just multiplying by 1 here. So the top of this, 5 times 8, is going to be 40, and then y squared. That does not break down under a fourth root. The bottom of this, fourth root of 16y to the fourth, 2 times 8 is 16. Y squared times y squared, you add the exponents when you multiply. And so my final answer is fourth root of 40y, squared. And then that's being divided by, the fourth root of 16 is 2. And the fourth root of y to the fourth is y. Alright guys, I got one more example here. These are just kind of more complicated situations. We're going to rationalize if we need to, but as always, if you get a fraction of some kind with a radical, you want to try to simplify anything you can first. So this, if you want to, just think of it under a big square root. They're both a square root. On this particular question, what I would argue is that you can simplify the x's. So x to the fifth over x squared would leave me with an x to the third on the top. Now I haven't taken a square root yet, so that's still there. Now the bottom would become the square root of 3y. And if you simplify it first, it's a little bit easier to deal with in terms of rationalizing if that has to happen. Now, to create a perfect square, and multiply this by 3y. Anytime you're working with a square root, if you multiply the denominator by itself, that creates a perfect square. And so what we got going on here, whatever I do to the bottom, I have to do to the top. That way we're multiplying by 1. This is equivalent to 1, so we're not changing the value of the expression. The top here, you've got a 3x cubed times y. The bottom is the square root of 9y squared. Now, what I would tell you here, just a little bit on the top, the bottom's a perfect square the way we created it. X to the third, we can simplify that a little bit in terms of a square root. I'm going to write x squared and x. So my final answer to the question, I am going to be able to pull an x out there on the top, and then I would still have a 3x and y under the radical. The y can't be broken down, but this x to the third can. The bottom, the square root of 9 is 3, and the square root of y squared is y. Now, don't cancel these y's out. This is all under a radical, and the denominator is not. So that mess is going to be our answer. For this question, again, I would recommend, this is a cube root, so think about that too while you're breaking this down. Let's reduce this first. So 2 over 16 is really the same thing as 1/8. I have 4 more a's on the bottom, and I have 3 more b's on the top. So what I would tell you here in terms of our rationalizing, the top is a perfect cube. The bottom, the number is a perfect cube, but the variable is not. So I need my exponent to be divided or divisible by my root. So I'm going to multiply this top and bottom just by the cube root of a squared. And I would tell you I'm doing that because 4 plus 2 will give me 6, and then 6 will be divisible by that third root. So just going to do 2 steps here. The top, you'd have the cube root a squared b to the third. The bottom, you'd have the cube root of 8a to the sixth. Now, on this question, we can simplify a little bit on the top and the bottom. We pull a b out here. The cube root of b to the third is b. We'll still have a cube root of a squared on the top. the bottom should now be a perfect cube. Cube root of 8 is 2. Cube root of 8 to the 6th is a squared. Again, nothing else cancels out here, so that would be my answer. Alright, now I'm going to do 2 more real quick. So 2 over 10 would be 1/5. Not taking a square root, just reducing. I have 2 more x's on the top, so that will cancel the 1 on the bottom. I have not taken a square root of anything. I'm just reducing that fraction. Okay, now, in terms of rationalizing, I need to turn 5 into a perfect square, so I'm going to multiply that by 5. I need to turn y into a perfect square, so I need my exponent to be divisible by the root, so we'll just go ahead and use a y. Okay, now in terms of the top of the fraction, this would be the square root of x squared, 5x squared times y. The bottom is going to be the square root of 25y squared. On the top, you can actually simplify out square root of x squared can pull out as an x. The 5y is going to have to stay underneath. The bottom of this, square root of 25 is 5, and the square root of y squared is y. Don't cancel these out because this is under a radical, and the denominator is not. Okay, one final question, and just be mindful of what the root is. Like that one was a square root, this is a cube root, so we have to create a perfect cube. Okay, let me reduce first. 4 over 6 is 2/3. In terms of my x's, I've got 3 more on the top, and in terms of my y's, I actually have 3 more on the bottom. Okay. All still under a cube root. We haven't done that, we've just reduced the fraction here. Okay, now, turning 3 into a perfect cube, we're going to need to get up to 27. So I'm going to multiply by the cube root of 9. And then honestly, the variable's already divisible by the root there, so we're good to go on that. So I'm just going to multiply the top and bottom by the cube root of 9. Top of this is going to become, oh, fail. Cube root, 2 times 9 is 18, x to the 3rd. The bottom, cube root, what we want, 27y to the 3rd. That's a perfect cube. Now, on that top part, you can actually simplify a little bit. Let me take the x out in front. Cube root 18 is not divisible by any of the perfect cubes, so that's going to stay unsimplified further because it can't be. The bottom, the cube root of 27 is 3, and the cube root of y to the 3rd exponent divided by the root will just be a y.